We will begin with a very interesting topic, which is trigonometry. And let me tell you, it is a very simple and a very interesting topic. Now, before we proceed, let me tell you that there are more than 50 videos which have been uploaded for 10th mathematics, and you will find the playlist link in the description given below. That is NCERT for 10th maths. So make sure that you go through all the videos, and we have covered most of the chapters, including trigonometry, statistics, probability, progressions, and so on and so forth, right? So let's come back to trigonometry. Has been derived from three Greek words. Tri means three, gon means sides, and metron means measurements. So we are talking about figures which have three sides, right? So basically it happens to be a triangle. And now in trigonometry here we consider right angled triangle. So in trigonometry we consider right angled triangle. So let me consider right angled triangle. So this is A, B and C, and there's a 90 degrees at B here. So this is a right angled triangle. Now why is trigonometry so important? Now many examples have been given even in your textbook. So let's assume that there is a tall building, right? And I'm standing here. And I would like to find the height of the building without measuring it. Is it possible? Yes, it's possible. So if we know the distance A, then I can find the height of a building without even calculating it. It is possible. So there's another scenario which has been given where there's a river flowing. Now this is the width of the river, right? And there's a, say, a flower pot or a device here, and there's a person standing in his balcony, right? So is it possible for the person to find the width of the river? Yes, it is possible. So this again forms a right angled triangle. This also forms a right angled triangle, right? So in such cases, wherever you have a scenario where we can have a right angled triangle, it is possible to find the height or possible to find the width for many realistic situations, right? So let's begin with the first topic here. So before we proceed with the first exercise, we have to know a few trigonometric identities. So let us consider a right angled triangle ABC. Okay, now let the angle here BC. So we find a few ratios with respect to angle C. We can also find a few ratios with respect to angle A, right? So now we need to find a few trigonometric identities. So now let me consider the same right angled triangle figure which has been given in the textbook. So this is a right angled triangle where the angle B is 90 degrees. So this is 90 degrees. So I have an angle A here, and I also have an angle C. And we know that in a given right angled triangle, this is the hypotenuse. The side which is opposite to the right angle is the hypotenuse. So this is hypotenuse. So this is angle A and this is angle C, and these are the two sides. Now I define certain ratios with respect to angle A, or I can define the ratios with respect to angle C. Now let's assume that I am defining the ratios with respect to angle A. If I consider angle A, the side opposite to angle A is BC. So BC is the side opposite to angle A. And the side AB is adjacent to angle A, right? So I'm considering angle A here. So when I consider angle A, the side opposite to angle A is BC, and the side adjacent to angle A is AB. Now with this, with angle A in our mind, we find the following identities. So we define sine of angle A. So what is sine of angle A? Sine of angle A is nothing but the opposite side divided by the adjacent side. So opposite to angle A. So remember, we are always talking with respect to angle A. So the side opposite to angle A divided by hypotenuse. So which is BC divided by AC. So this is sine A. Next we define cosine. So cosine A is the side adjacent to angle A divided by hypotenuse. So the side adjacent to angle A is AB. So I have AB divided by AC, and we also define tangent. Tangent of angle A is nothing but the side opposite to angle A divided by the side adjacent to angle A. So this is opposite side, which is BC divided by AB. Right? So we have defined these three ratios. So now we also have the inverses of these three. So inverse of sine is cosecant. Find cosecant A is nothing but reciprocal of sine A. So what is reciprocal of sine A? It is hypotenuse divided by side opposite to angle A. So I'll directly write it as AC by BC. Next we define secant A, which is opposite to cosine A, which is hypotenuse AC divided by the adjacent side AB. And similarly the inverse of tangent is cotangent A, which is the adjacent side divided by opposite side, which is AB by BC. Right? So now we have defined these three ratios, right? So we have defined sine, cosine as well as tangent, and their inverses known as cosecant, secant and cotangent. Now for simplicity we write sine A as a secant of angle A, cosine as cos of A, tangent as tan of A, right? Cosecant as COSC, cosecant A, and then secant of A is SEC of A, and cotangent as cot of A. So for our easy representation, we define sine as sin of A, cosine as cos of A, cosecant as cosec, COSEC of A, secant as SEC, secant A, tangent as tan of A, and cotangent as cot of A. Now we have defined these ratios with respect to angle A. Now similarly we can also define the ratios with respect to angle C. So when I consider angle C, right? So when I consider angle C, then the opposite side is AB. So AB becomes the opposite side and BC becomes the adjacent side. Right? So similarly we can define all of them, sine, cosine, tangent, etc. with respect to angle C. So let's just define these three. So what is sine C? Sine of angle C is nothing but opposite side. Opposite to C is AB divided by AC, which is the hypotenuse. Cosine is cos C. So what is cos C? It is adjacent, which is BC by AC. And similarly tan of C. What is tan of C? It is the opposite side by adjacent side, which is AB divided by BC. So this is going to be AB divided by BC. Right? So now we have defined all these ratios with respect to angle A and with respect to angle C. Of course, you can find cosecant, secant and cotangent of C by taking their inverses. Now so exercise 1, the first problem. So there is a triangle ABC which is right angled at B, and we find that AB is 24 whereas BC is 7. Okay, so now we need to find sine A and we also need to find cos A. Right, so this is a right angle triangle, so I need to find the hypotenuse. So what is hypotenuse? We know that AC square is AB square plus BC square. So it is better to remember the pairs, right? So here we find that 7 square plus 24 square is nothing but AC square. So if you find the value, you get 625, right? So therefore AC is root 625, which is 25. So AC, the hypotenuse is 25 centimeters. So now we need to find the ratios. So what is sine A? So this is the angle A. So sine A is opposite side, which is BC, by hypotenuse AC. So it is BC divided by AC. So it is 7 by 25. So similarly, what is cos A? Cos A is adjacent side. What is adjacent side of A is AB divided by the hypotenuse, which is AC. So you get 24 by 25. Now we also need to define sine and cosine with respect to C. So what is sine C? So sine C is, so this is angle C. Opposite to C is AB. So AB divided by AC, which is, so sine C is opposite to angle C, which is AB divided by hypotenuse AC. So we have 24 by 25. And we also need to find cos C. So what is cos C? The side adjacent to C is BC. So BC by AC. So which is BC by AC, which is 7 by 25. Right? So these are the values which we have calculated. So the next problem, given a right angle triangle, so the right angle triangle PQR has been given, right? So we have P, Q and R. So this is 5, this is 12. Okay, so now we can find the hypotenuse as nothing but 13. So these are all Pythagorean triplets, right? So 5 square plus 12 square is equal to 13 square. So the hypotenuse will be 13. You can remember some of them because it will be handy in the examination, right? So 5, 12, 13 is a pair. So next 7, 24, 25 is a pair. Okay, so now we need to find tan P and cot R. So what is tan P? Tan P is opposite side of P is 5 divided by adjacent side, which is 12. So it is QR divided by PQ, which is 5 by 12. So similarly, we need to find cot R. So what is cot R? So this is angle R. So cot R is adjacent side divided by opposite side. So which is QR divided by PQ, which is again 5 by 12. So here we observe that tan P and cot R are both one and the same. So we need to find tan P minus cot R, right? So tan P minus cot R is nothing but 5 by 12 minus 5 by 12, so we get 0. Very simple problem. Next, moving on with the next one, the third problem, which states that sine A is 3 by 4. Right, so we need to find cos A and tan A. Now what is sine A? Let's draw a right angle triangle. So whenever sine or cosine or tan is given, the best thing is to draw the right angle triangle, right? So let's assume that this is A, B and C, right? So this is angle A. Let's assume that. So sine A is opposite side divided by hypotenuse. So this is 3 and hypotenuse is 4, and we need to find AB. So how do we find AB? We know that AC square is AB square plus BC square. So what is AB? AB is nothing but root of 4 square minus 3 square, isn't it? So it's going to be 16 minus 9, so we get root 7. So AB is root 7. So now the value of AB is root 7. So after having known the value of AB, we can find the others. So we need to find cos A. So what is cos A? Cos A is adjacent side by hypotenuse, which is AB, divided by hypotenuse AC, which is root 7 by 4. Right? So once the sides of all the three triangles are known, we can find any trigonometric identity. So next we need to find tan A. So tan A is opposite side by adjacent side, which is 3 by root 7, right? Cot A is 8. Okay, so we need to find sine A, and we also need to find secant A. So cot A is 8 by 15. So cot A is 8 by 15. So again have a right angle triangle. So this is A, B and C. So what is cot A? Cot is adjacent side by opposite side. So adjacent side is 8, opposite side is 15. So I need to find AC, which happens to be the hypotenuse. So AC square is nothing but 8 square plus 15 square. So AC is root of 8 square plus 15 square. So this is 64 plus 225 the whole root. Right? So we get 17. So AC is 70. So once the hypotenuse is known, we can find sine A and secant A. Now sine A is opposite side, which is 15. I'll directly write it is 15 divided by the hypotenuse, which is 17. And what about secant A? Now secant A is inverse of, what is inverse of secant A? Secant A is the inverse of cos A, isn't it? So therefore cos A is adjacent by hypotenuse. So secant A is hypotenuse by adjacent side, which is 17 by 8. So we have secant A as 17 by 8. Next, problem 5, we have secant theta, which is 13 by 12. Right? So now let me draw the right angle triangle. Let us assume that this is theta. Theta is nothing but an unknown variable, right? So it's an angle here. So let me assume that this angle is theta. So I can write it as x also, right? So therefore this is theta here. So this is triangle ABC. So this is the angle theta. So secant theta is 13 by 12. So we know that secant is the reciprocal or the inverse of cos theta, which is 12 by 13. So now cos is nothing but adjacent side divided by hypotenuse. Okay, right. So now I need to find AB. So we know that 13 square is 12 square plus AB square, or AB is nothing but 5. Right? As I already told you, one of the Pythagorean triplets is 5, 12 and 13. Right? So you don't have to calculate. 5, 12 and 13 is a Pythagorean triplet. So now AB is 5. So I need to find all the ratios. So what are the ratios? Sine theta. So what is sine theta? Opposite side by hypotenuse, which is 5 by 13. Next, cos theta is already known, which is 12 by 13. Next, we have tan theta, which is opposite side 5 by adjacent side 12. Next, cot theta, which is 12 by 5, the inverse of tan theta. And next, cosecant theta is the inverse of sine theta, which is 13 by 5. So we have found out all the trigonometric ratios here. So next, sixth problem, if angle A and angle B are acute such that cos A equals cos B, show that angle A equals angle B. Right? So we need to prove that angle A is equal to angle B. So let's assume a right angle triangle. So let this be A, B and C. So this is 90 degrees. This is angle A and this is angle B. This is the hypotenuse. AB is the hypotenuse, isn't it? So what is being given? Cos A is equal to cos B. What is cos A? Cos A is adjacent side, which is AC, divided by hypotenuse AB. Similarly, cos B is the adjacent side to angle B, which is BC, divided by AB. Now we know that this is 90. If this is 90, these two angles actually are equal, isn't it? Right? Anyway, so that is what we need to prove. So it's been given that cos A equals cos B. So I can equate these two. LHS of both of them are equal. So if I call this as equation 1 and 2, LHS of 1 and 2 are equal. Cos A equal to cos B given. So therefore RHS of 1 and 2 should be equal. So AC by AB is equal to BC by AB. So AB gets cancelled. So AC equals BC. So therefore AC is equal to BC. So these two sides are equal. Now if these two sides are equal, the angles opposite to equal sides are also equal. So this implies that angle A is equal to angle B. So we have proved. It's a very simple proof. Next, seventh one. Given cot theta equals 7 by 8. Okay, so we need to find, so now cot theta is 7 by 8. So I need to find two relations. One is 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta into 1 minus cos theta. Okay, so this is like a plus b into a minus b, a plus b into a minus b. So we know that a plus b into a minus b is a square minus b square. So I can write this as 1 minus sine square theta divided by 1 minus cos square theta. So what is it that I need to find? I have to find the value of sine theta and cos theta. Given cot theta is 7 by 8. So let's assume that this is theta. Cot is adjacent side, which is 7. Opposite side is 8. So I need to find, so if this is ABC, I need to find AC. So what is AC? AC is root of 7 square plus 8 square. So what do I get? So I get the value as root of 113. So now, what is sine theta? Sine theta is opposite side. So this is root 113. Theta is the angle at C, right? So what is sine theta? Its opposite side, which is 8 divided by root 113. And cos theta is the adjacent side, which is 7 by root 113. So let me substitute these values in this expression. So if I do that, I get 1 minus sine square theta. So it is 8 by root 113 the whole square divided by 1 minus 7 by root 113 the whole square. Okay, so if I take the square, I get 1 minus 64 divided by 113 divided by 1 minus 49 by 113. If I take the LCM, so I get 113 minus 64 divided by 113 and then 113 minus 49 divided by 113. So I can cancel both the denominators. So 113 minus 64, so what do we get? We get 49 and here I get 64, right? So the value of the first expression is 49 by 64. Next, I also need to find one more. It's been asked that we need to find the value of, so the second one I need to find cot square theta. So now what is cot theta? Cot theta is here the adjacent side divided by the opposite side, which is 7 by 8. So square, I get 49 by 64, right? So essentially these two expressions are one and the same, right? So 1 minus sine square theta divided by 1 minus cos square theta is nothing but cot square theta. We shall prove this much later, okay? Right, so we have finished 7 problems. Problem 8, if 3 cot A equals 4, then we need to check if 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sine square A. Right? So we have 3 cot A equals 4. So definitely cot A equals 4 by 3 or tan A, which is the inverse, equals 3 by 4. So if I represent this by a right angle triangle, and if this is A, we have the opposite side is 3, adjacent side is 4, and this definitely is 5. So I've already told you that 3, 4, 5 is a Pythagorean triplet. You can check for yourself. So now let me substitute the values. So 1 minus 3 by 4 square divided by 1 plus 3 by 4 square. So what do we get? So this is 1 minus 9 by 16 divided by 1 plus 9 by 16. So taking the LCM, so I get 16 minus 9, so which is 7 by 16 divided by 16 plus 9, which is 25 by 16. So 16 gets cancelled, so I get 7 by 25, right? So this is the answer. So now let us consider cos square A minus sine square A. So what is cos square A? Cos A is adjacent side by hypotenuse, which is 4 by 5 the whole square, minus sine A is opposite side, which is 3 by 5 whole square. So this is 16 minus 9 by 25, which is again 7 by 25. So these two are one and the same. So we have shown that the expression 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sine square A. So now moving on to the next one, we have problem 9. So we have a triangle, right angled triangle, which is right angled at B, it is said, and tan A, so let this be A, is 1 by root 3. Okay, so we have tan A, which is opposite side by adjacent side, 1 by root 3. So now let's find the hypotenuse. So what is the hypotenuse? 1 plus root 3 square is 3 equals 4, the whole root, which is 2. So this is C. So the hypotenuse AC. So with these relations now, we need to find the first one, sine A cos C plus cos A sine C. Okay. Now what is sine A? So we'll write the ratios directly. So sine A is opposite side by hypotenuse, which is 1 by 2. Cos C, so this is C here. Cos is adjacent side by hypotenuse, which is 1 by 2, plus cos A. Cos A is adjacent side, which is root 3 by 2. And then sine C. Sine C is opposite side of C is root 3 by hypotenuse, which is again 2. So I get 1 by 4 plus 3 by 4, which is 1. So it is 4 by 4. So we get 1 as the answer. So the next one, we have cos A into cos C minus sine A into sine C, right? So again, cos A. Cos A is, we've already written cos A is root 3 by 2. Cos C is 1 by 2 minus sine A is again 1 by 2 here, and sine C we have written it here, which is root 3 by 2. So it is root 3 by 4 minus root 3 by 4, we get 0. Right? So the next problem, consider a triangle PQR. So it is right angled at Q. So I have a right angled triangle. So it is right angled at Q, and it has been given that PQ is 5. So let this be PQR. So this is 5. And then PR. So PR plus QR is 25. So PR plus QR equals 25. So this is what is being given here. So now we need to find the value of sin P, cos P and tan P. Okay. So this plus this equals 25. Okay. So now let's assume that this is K, and this of course is 25 minus K. Right? So RQ is K. So what is PR? PR is 25 minus K. Right? So now we know that PR square equals QR square plus QP square. So we have PR square equals RQ square plus PQ square. Let me substitute all of them. So PR square, so PR is 25 minus K the whole square equals RQ. So RQ is K square plus PQ is 5 square. Okay, so let me expand this. So I get, this is of the form A minus B the whole square. So it is A square minus 2AB plus B square. So I have A square is 625, 25 square minus 2AB. So I get minus 50K plus B square is K square equals K square plus 25. Okay, so K square gets cancelled. So I bring this 25 to this side, so I get 625 minus 25, which is 600, and I take this, so I get 50K. So what is k? K is 600 by 50. So I get 12. So the value of k is 12. So if this is 12 and this is 25 minus 12, which is 13. So again we have to realize that, we know that 5, 12, 13 is again a Pythagorean triplet. So now after having found them, so let's find sine p. What is sine p? Opposite side. So this is p, opposite side is 12 by 13. Next, we need to find cos p. Cos p is adjacent side is again 5 by 13, which is hypotenuse. And tan p. What is tan p? Tan p is opposite side, which is 12 by the adjacent side 5. So we get 12 by 5. Right? So now we have finished all the 10 problems. Now the 11th one happens to be true or false. So let's see what it is. So question 11 is true or false. So the first one, which states that tan A is always less than 1. Is tan A always less than 1? Tan A is definitely not always less than 1. We have an example here itself. Tan P is 12 by 5, it is greater than 1, isn't it? So tan A always is less than 1 is a false statement. So the first one is false. Now what about the second statement? The second statement is that secant A is 12 by 5 for some angle A. Now what is secant A? Secant A is nothing but 1 by cos A. So cos A is 5 by 12. Right? So I can have a triangle, right angle triangle, where this is A. So the adjacent side is 5, the hypotenuse is 12. So I can have a right angle triangle where A, this is 5, this is 12. I can have some value. So this is going to be 12 square minus 5 square, the whole root. So I'll get some value here. So this of course is a possibility. So this is a true statement. The second one is a true statement. So now the third statement, which states that cos A is an abbreviation. So the third one states that cos A is an abbreviation of cosecant of angle A. So this of course is a false statement, because cos A is an abbreviation of cosine and not cosecant. The fourth one, cot A is a product of cot and A. Of course it's a false statement. Cot A is not the product of cot and A. Cot A actually represents the cotangent of angle of A. So this of course is a false statement. And the last one, 5, sine theta equals 4 by 3 for some angle of theta. Okay, so now if I talk about sine theta here, sine theta, this is theta here. Sine is opposite side by hypotenuse. Can we have an hypotenuse which is smaller than one of its sides? No, not possible. Right? So the denominator always has to be greater than the numerator. So therefore this is a false statement. Okay, so very interesting, 5 true or false statements. So with this we have gone through the fundamentals of trigonometry, and we have also solved all the problems given in the first exercise. Right? So make sure you go through the playlist for 10th standard, and there are more than 40 to 50 videos which have already been uploaded on various topics of your 10th mathematics, which includes trigonometry, probability, statistics, coordinate geometry, and so on. So make sure that you do watch them, and do not forget to like, share and subscribe, and press the bell icon to get notifications of further uploads. And thanks for watching.